night. Working on our Stormlight, the diagram that you can see there on your page. Another night. Working on our Stormlight,
One moment,
the
I have a
diagram
small
that you can
local audio
see.
adjustment to make. There we go.
Immediate technical difficulties.
Yes. I was getting a wicked feedback loop on my headset. The joys of live broadcast here. So, anyway, I realized I wasn't actually showing you the diagram. So, if you haven't seen this series before, this is a quick diagram of the light we're building. It's a hanging pendant light. It's supposed to look like a cloud with a lightning storm in it, and it should respond to noise. And tonight, Lily is back here with me, and we'll be testing out our lightning features so that we can actually make it flash. So when we left off last week, Butch and I were doing evil pair style ping pong pairing.
Nice.
And for those of you who haven't followed this before, evil pair is where one of us writes a test and then the other one implements just enough code to make the test pass. But we very deliberately write code that is not to the intent of the program. We don't try to anticipate what's coming in a good way. We try to anticipate what's coming and do something different to force the writing of a test that will require us to do the right thing or something closer to the right thing. This is a technique that we use to make sure that we don't miss edge cases. It tends to result in more well-tested code, more robust code, and especially if you're just feeling a long, draggy day at work, wow, is this a great way to get through the day? Deliberately trying to mess with your friends, coworkers, and casual enemies. All right, so let's switch back to actually working on some code, like we talked about, and so we left off last session with a failing test so that we know where to start this week. That was a really good thing because Butch was here last week and is not this week. He's off celebrating his anniversary with his wife. And Lily wasn't here last week. She was off doing fun holiday stuff. And so now she gets to be here. She doesn't get to celebrate with Butch's wife. Anyway, so we've got a failing test. Line 87 here is failing. So we're calling the lightning function. And on line 87, we're saying that the second function we call in there should be LED on. And this says we are not getting LED on. And we should probably go do something about that. So, Lily, do you want to drive here? I'll hand this over to you.
Sure, yeah.
You can implement that.
It looks like it's looking at a call history that's just not there, right?
Yeah, that's correct.
Okay. Here we go.
All right, let's run that test and see what happens. Oh, hey, look. No, that's not the test. Go ahead and run the test and see what happens. Oh, I didn't like that at all. Implicit declaration of function LED on. And I'll bet that's because we haven't brought that function in. Go over and look. This, of course, is a function that appeared while you weren't here, so you haven't really had the good chance to see it. I think we defined those in hardware.h.
Oh, okay. So let's just throw that in here.
And what this is a hardware abstraction layer that Butch and I decided we needed so that we could write mocks for our hardware without having to actually implement the hardware. Without having to think about how that's going to manipulate registers underneath. So we can concentrate on the logic of our program. And the good news is we've got lots of good experience turning LEDs on and off, so we aren't worried about on that front. Oh, you're still getting beat up on line 87.
Mm-hmm.
Huh.
So this one's fine, Rand.
Yep. Oh, take a look at the order that things are being called in.
Whoops. There we go.
That didn't save.
Oh, no autosave.
Remember, autosave doesn't tend to pick up the saves from the... Doesn't tend to pick up your focus save from remote. I'll make sure that that's turned on though. It is on. All right.
Okay.
Okay, so
Well,
you moved on to
feeling
line.
different.
Yeah, you moved on to line 89, aren't you?
Oh, very nice. So 88 is fine. All right. So then we just want to turn the LED off.
Yeah.
So it's just going to be a random delay and then off. All right.
Yes. Yeah, you may have
Almost
noticed a
remote.
deficiency in the test.
Oops.
I think this is a great opportunity for you, maybe to, once you've implemented this, you get to write the next test. So you can say maybe this thing should do a different thing, because yeah, the first thing it's going to do is immediately we're going to turn it off, and it's immediately going to flip back on again. You'll never even see it go off.
Mm-hmm.
So
There you go.
yeah,
Didn't save.
that's
There we
better.
go.
That's better. You made it mad at me. Okay. All right, it's mad on line 90, which just means that it's missing its delay. It doesn't matter what I put in there. In just a second, I need to unfollow you. Otherwise, as we discovered earlier in the day, things get weird. Since we don't have any test that says what I have to do in there.
Mm-hmm. I was thinking about how to test random values.
Yeah, so let's go ahead and talk about that. Ooh, I
The
made
best
it
I could
mad.
the best I could come up with was you could test that what's being returned is in the range of values that you're expecting. So if we want this to blink or blink on for somewhere between 0 and 1 second, we could test that the value we're passing to delay is in that range.
Yeah, I think there's another way we can do it though, and this is just something that you and I actually do every day if we think about it, which
Mm-hmm.
is what we mock Rand and we say, what's it going to return?
Oh, true.
And so by putting I realize what's happened in here. I've got a lot of tests that say delay MS is called for the random amount of time, or it
Mm-hmm.
was called a certain number of times. And so I've made our test pass, I believe. Let me go back and look at the test. Oh no, line 83 is in our test. So I've still broken something. Oh, and you know what I'm going to do? I am just going to the only thing it really cares is that it's got a certain value in here. So I'm just
Mm-hmm.
going to do that since we know that random delay is 37 seconds right now.
I think we're also failing on the call count.
Oh, I think you're right.
Yeah.
So that'd be around line 72, 82. Yeah, delay MS. I should count. That should get called twice. So let's fix that. And Randy gets called once. Probably offending some other sensibility, but let's fix one thing at a time. Okay, test LED at line 61. And I think this is just a brittle test that we wrote. Lightning makes lightning for rand time. Okay, we called lightning, and yeah, this is another case, just like you said. We made a brittle test there. And finally, on line 72. And folks, if you're listening to this later, I'd love it if you'd drop a note. Lily and I are both operating with new sound equipment this week, and we'd love to know what you think about the sound of the program. Okay, and this is line 72 is the exact same problem that we had before.
Mm-hmm.
We made a brittle test and we got a brittle result. Okay, now that did not make it much. Oh, it made the line after it less happy. Okay, that's fair, actually. It said, hey, I really expected that uh, to be 17, and that's not what you did. And so that's telling me I can't get away with what I did. I actually have to make this be random delay. Okay.
Nice.
So the lightning function actually kind of does the thing we want now. Now, I
Mm-hmm.
feel like I would actually like to change... Huh. In the interest of facilitating an additional test, uh, I want to make a lightning on and lightning off function. Since I'm green right now, I think it's safe to refactor.
Mm-hmm.
Um, and I'm actually going to take an unsigned integer duration here. And we are going to do LED on, delay ms, duration, like that. And so I can replace these two lines here with a call to lightning on for random delay. I've noticed we've forced this to put everything in 1 second increments. I almost wonder if that's too fast to make it look like lightning. But I guess we have to actually test this on hardware to see if we're happy with that.
Mm-hmm.
And so now I want to change. Uh, I need to tell the headers about these new functions. So we got that there. And folks, also, if you're listening out there, the other thing we'd love to know, if you know somebody that you think might be interested in making devices, animatronics for Halloween or whatever sort of um, moving and flashing sort of thing they'd like to do, go ahead and tune them into this show. We just love to see them join us. We love your feedback too about what we can do to make this friendlier to somebody who's new to building electronics. All right, I feel like that's good. Let's see if this works. Ooh. I've got a lot of lack of love from the compiler here. All right. So Stormlight.c on line 20. We have made an implicit declaration of lightning on. Oh, I bet Stormlight.c doesn't include Starlight.h. All right, there we go. That's probably going to give me a little more respect from the compiler. There we go. That's all green now. All right, now it's time for me to write a test, isn't it? And actually, a thought that I'm having here.
Mm-hmm.
I want Hmm. I was having a thought and then it ran away. I'm sorry.
It happens. Happens to me a lot.
Yeah, it's been for the listeners out there. It's been a long week for us. Kind of full of emotional ups and downs with day job related stuff. But I guess I'd like for the time off and the time on not to have to be the same.
Hmm.
Um, so I think I would like. Well, I'd like to actually do. Oh shoot! I got all happy with the keys and forgot to pay attention to where the key was. So I'd like to modify this test a little bit. Um, I want to. Let's see. I want. So this is an integer, so I want to make an array of integer. And I just want to do a sequence where I want two things to come back from rand.
Hmm.
And we'll be able to pass two different values into those two different functions. So
Right.
int rand seq, and that's going to be equal to. Let's have the first one be 16, and the second one be 7. Seems like a very random number. And then, off the top of my head, I don't remember how to write this. The session or sequence.
Oh, it's like set return sequence.
Set return
I don't know
seq
what it is.
right there.
Yeah.
All right, that's what we wanted. So it's rand fake, and then the sequence
Hmm.
and the number of members. Oh, that's very convenient. Actually, the IntelliSense is telling me what I need to know. I love it. Okay, and so this changes, and I want random to be called twice. I definitely want delay ms fake to be called twice. And this needs to change just a little bit here. So I want it to be called 16 times 1000 argv0 history 0. That's the first entry in our history. And I want the second one to be called. Oops. First, let's make sure we check the second one. And the second one should be 7 seconds. And so that should break really good. And it should break on line 85 and 86 in particular. If I'm wrong, it'll break in a lot more places. Oh, look at that! I broke it in a lot more places. All right.
Oh, nice.
This might be one of those situations where I have to go read the fine manual again. So set return seq. Oh. I'm not supposed to actually. The fake part's supposed to be quiet. That's the silent part, and I was saying it out loud. There's part of my problem. Oh, that's much better. Look, broke on line 83. That's really not where I expected it to. Oh, right. No, line 83 is where I would expect it to fail, so that's fine. All right, so I'm going to hand this over to you to implement. Let me follow you.
All right.
All right, we're following you.
Sounds like we need to just paste this somewhere.
Yeah.
Will that do it? That might do
I
it.
think that will.
All right.
I feel like that didn't get what we wanted.
Let's see what broke. Expected one was 2. No, I think this is okay. So I think this is some call count stuff. So on line 60, we're calling this twice now,
Oh, so we are.
which is the intention, right?
Yeah, and some of these
Okay.
tests are becoming irrelevant now.
Hmm.
And for those following along at home, this totally happens all the time. You get into your implementation and you realize, hey, that thing I was asserting before that made good sense, it stopped making sense now. I need to do a different thing to get the result that I want.
This is failing on line 91 because we are randoming again.
Oh, that's a good catch. Yeah, this test is actually getting a little bit brittle. Uh,
Yeah, so maybe now that everything's green, we refactor these tests a little bit.
yeah, I think that's a really good idea. And so again, for the listener, this is something that we do all the time. We say, "Hey, that test made a lot of sense there, and now it's become really brittle because the needs of the program have changed, and so I'm going to change that." And as long as all of your existing tests are green, that's a safe option to do.
Mm-hmm.
As long as you don't actually lose coverage. We have a tool called LCOV that we use that actually charts the coverage that we have with our tests, and that's a really good tool to use in a situation like this to make sure you didn't lose coverage on something. Maybe at some point in the future we'll do an episode on using code coverage tools like LCOV and what they can do for you.
That would be interesting. What they can do for you and also what they can't do for you.
I was
You can have
yeah
100% coverage and 100% meaningless coverage.
yeah. So some of the drama that we've dealt with in our day job is related to uh, a lack of understanding about what test coverage really gives you. We'd like to talk about it as this great metric that sort of like this golden. We're trying to get the highest test coverage we can, but having perfect test coverage doesn't tell you everything about the program. The only thing it means is that your tests went over every line of code. It's perfectly possible for that test not to test important things in your code.
You could have 100% coverage with 0 assertions.
Yes, I have. I have in fact seen that in production.
That's impressive.
It was. It was. It
Fail if
was.
you comment out every assertion.
Oh, they didn't. They didn't really go that far. They just made sure they called every method.
Mm.
But there were no. The code was assertion free.
So in here, I kind of want to. I don't know if I want to get rid of all the ones that are looking at call counts because once we kind of have this in a working state, then the call count won't change as much as it's changing now. But maybe we just have the call count being tested in one spot instead of.
I think that's an appropriate thing to do. And I think that last test that we've been working on is probably a good place to do that.
Yeah, take these out.
Yeah. Oh, I'm sorry. I said one thing, but I think I meant a different thing. So this test here is a test we've been working in, and I think that's an appropriate place to make sure. Yeah, I've called it twice.
Mm-hmm.
I think a lot of those other places maybe aren't as good. Uh, I don't know. Maybe you feel differently about that. I know you don't have the advantage of having been here for those tests.
I was gonna rip it out from everywhere except like maybe this one.
Let me
I
take
guess
a
it
look
doesn't
at that.
matter where it is, as long as it's
That
just
one's
in one
not.
place.
That one's not horrible.
This one already has so many assertions in it.
It's getting overloaded, isn't it?
Mm-hmm.
Yeah. Um, sure. Go ahead and like shift that check to make sure that we call it twice somewhere else. I think that's fine.
We've got it here, right? Is this? Yeah,
And the
that
reason why,
should be good. Rip it out of here.
and for the
And out
listeners
of
out
here.
there, what's going on is um, we want to keep the number of assertions per test smaller. It makes it easier to when you get a failure message. It really makes it easier to tell when you've uh, what's failed. I kind of want to just look at the name of the test that's failed and know what I've broken. I don't want to have to dig through the code to see the intimate details. That's really particularly important if, say, you're inheriting a code base with a suite of tests, but you didn't write those tests. Uh, you want that failure message to be really obvious, because otherwise, the person who's inheriting your code base comes and asks you tedious questions. Sometimes you don't see them till the end of the day. You have to apologize because you ignored them all day.
Or day and a half. It
Day and a
happens.
half, yeah, that's true.
So I think this is good. We're testing this now on 1661. So if we add any calls in there, oh man, now I kind of want to take it back because it's gonna break here too, and I like the just the one test to break.
Okay.
The call
Uh,
history, so the call history is gonna break,
yeah,
and the
call history
break.
tests are really fragile.
Yeah.
Um, I would actually be okay. I think if we can that long chain of call history, what is that? Five, 6 elements that are in there.
Mm-hmm.
Yeah, it's a 5 element call history there. Uh, I think I would be fine with uh, splitting that up. I think what I'd really like to see, yeah, it might be sufficient to say, oh, they call. Well, no, we could split out tests that specifically assert what lightning on and lightning off do.
Mm-hmm.
Then in here, we just have to assert that we called lightning on and lightning off with the appropriate random values. But to do that, we would need to do dependency injection.
Yeah. We could.
We could. I kind of feel like I'd like to avoid that. But I
Yeah.
also, here's the other thing. Right now, I actually kind of feel like I'm okay. I don't feel like the lightning function needs to change much from
Mm-hmm.
here on out.
So this might not be so fragile. I think it'll
Yeah.
get less fragile as we go.
Yeah. I feel like the lightning function maybe does everything that it needs to do. And you call lightning, it'll flash it on and delay for a certain period of time, and then off and delay for a certain period of time.
Mm-hmm.
Uh, I think my gut here is that that'll be okay. Um, and then to make it look more like a proper lightning storm, we want to probably randomize the number of times we call lightning.
Mm-hmm. That's what I
Uh,
was thinking.
so we could maybe like a lightning storm function.
Yeah. Before we do that, though, we could test what we have on hardware and just sort of see what it looks like.
Yeah, let's go take a look at the main loop and see if it's got the capability to do that.
All right, we need to set up this.
Yeah, we aren't calling there. That's it. That's right. Oh, LED on and LED off are empty too. So we need to. I think that function in that block of code that was in the loop, I think that actually does the right thing for turning on or turning off. That's an or equal. So yeah, that will turn it on.
Mm-hmm.
So you can just copy that and it'll turn on the light. And then off, this is where I'm going to go, and I'm going to switch away to the browser here for just a second, so that I don't really want people at home getting this notion that we're just geniuses and we know how to do all this stuff. The reality it is, we remember, hey, I did this someplace before, and I go and I look at that place where I did it before, and I go from there. So uh,
No reason to figure stuff out twice.
yeah, I was smart once. I don't want to have to be smart twice. That's very unpleasant. So in Wolverine here, I think there's a Yes, there's LED on and LED off functions. So setups ons do the or equals, so that's good. Offs do and assign. Oh, it's that whole thing right there. I'm going to do you a favor, and this isn't the exact right code to put in, but the operators are the right code.
Mm-hmm.
So I'm just going to paste that into here for you. And if I actually click into the window, my pasting will go faster. And for the users at home, let me switch them to actually see our code. And maybe I'll even let them see our code and the device at the same time. We're going to get really ostentatious here. All right. So I think I just took the follow away from you. No, I kept it on you. Excellent. He can be taught. All right, go ahead and make that do the thing.
We're still on port B.
Yep. And the tinies only have port B, so that actually really makes it simple.
Yeah, that was confusing. I didn't realize there was no port A. It's just port B.
Yeah, I don't know what port A represents. It's one of those things that I should probably dig out. But we aren't there right now, are we? Okay.
I just imagine it's because of the porta potty jokes. Because you'd be writing.
I
My
hadn't
bad.
thought of that, but that is a very legitimate concern. Okay, so LED on and off are actually set to do things. We haven't written tests around that yet, but I think you bring up a valid point. It's probably a really good time to test on hardware. We need to go.
Mm-hmm.
We need to go back and set up our loop. Yeah, instead of doing that, we need to call lightning.
We could test that real quick.
That loop is calling lightning.
Yeah.
Yeah, let's do it. Do it. I want to change the name of this test suite too. We've called it LED, but LED is actually a separate file, and I think we should really call this one just Stormlight. I think future readers of this code will thank us for using a sensible name on it.
Oh, we're gonna have to do dependency injection. Okay. I tricked myself into this.
You did. You did. And we will need to write this test, so I guess it's time to make it happen now.
Sad face.
Yep. It is definitely a sad face situation.
Okay, so let's start in Stormlight.h. We need a function pointer, and I don't remember the syntax.
Yeah, that's fine. So it's just like regular, except you wrap the name in parens, and you put the asterisk in front of the name.
Okay, and then we're going to call this one implementation.
Yep. And it does the real thing.
Okay, so let's go here. No, wait, let me copy that. We're going to call this one implementation. And somewhere in here, I think you prefer to do them down here, right?
It doesn't matter. I usually prefer them up at the top, but it's just a personal preference thing.
And the assignment looks something like that, right?
Yeah, we don't need to put... Yeah. The void at the front still has to go there. Oh, no, it doesn't. No, it doesn't. Hold on. Let me think.
Because we're just assigning that.
This is one of those things where you go back to your browser, into your former repo, and you say, "How did I do this before? When I was smarter." Okay. So these up here at the top, I'm just going to grab one and paste it in there again for you.
Okay.
that wasn't quite how that was supposed to go.
Oh, so we do need pretty close. There we go.
Yeah,
Okay.
it was. You were closer than I was thinking we had to be. Uh, in the header, we do need to declare that as an extern variable.
Oh, right.
And again, for those following along at home who haven't done this, what we're saying here is that there is a variable somewhere called lightning, but don't worry about where it is. It's handled. And over in Stormlight.c, when we were doing that assignment, we were handling it. Okay, and now to do your test.
Okay, so let's go into the setup. I guess before we go into the setup, let's make a fake.
Yes, right, we need a fake. I feel like we've got an extra E in there.
Oh yeah, can't type. Lightning. Wait,
Yeah, you got it. That's right.
that looks wrong. Yeah. Really? Oh, you ever look at a word so much and then it just starts to look like nonsense?
Oh yeah. I am
Okay,
studying
so
French right now. Of course they look like nonsense.
when I say lightning, I like pronounce an E there. Lightning. I don't know. All right, moving on.
I
Let's
think
make
we
sure we
can't
do
just call it
that.
lightning because I think that will mask the function pointer.
Oh yeah, you're right.
So we need to call it like mock or something like that. Yeah. And you're on line 29, you need a semicolon.
Thank you. And then also in the setup, let's just make sure we say that lightning,
Right.
spelled right, is lightning mock.
And in teardown, we should assign it back in case anything needs the real thing.
True.
Except that, yeah, okay. I was looking at the wrong line. Okay.
That should be okay. So let me go get rid of this sad face down here. Now it's lightning mock fake. I don't have. Oh wait, never mind. I didn't have any fence in here. Call count, and that should
should be
fail.
1 right now.
Oh no.
That's
I spelled it wrong. I spelled it wrong again.
Yes, you did. That's great. I didn't catch it before, so you'll have to fix that.
Where else did I spell
At the
it?
top of the file.
You know what? It's just one of those words for me, I guess.
Yep.
Like exercise. That's another one.
Uh-huh. Okay, so we've still missed it in a few places. We missed it on line 37 of this file for sure.
I didn't even realize I typed this so much. We should have just left it spelled wrong.
I only caught it the one time too. Line 32 has the same problem.
Let's just search everywhere and make sure we got them all. There's 3 more.
Oh, geez.
I just learned how to spell lightning? Maybe.
Yeah. I know we've both been studying languages, and sometimes my inability to pass the tests in Duolingo have everything to do with I can't spell English.
So now we've got some other stuff failing.
So we do. Well, that's very exciting.
Oh, we need the implementation here. This is a good time to split out. Oh, I don't want to split all this stuff up. Let's just throw.
Oh yeah.
Let's
Actually,
split up the test groups.
Okay, yeah.
Test group, and then in that setup, we can say that we're using the implementation.
Yep. I like that idea. So what we're doing, folks, is sometime we want to have one set of tests that always use our mock lightning, and we're going to have another set of tests that always use the real lightning.
Let's go to test group, lightning. After that, so I don't have to keep typing it. Down. And let's go with the group runner. So I could just put both test setups up here instead of having one like in the middle of the file.
Yeah, I think that's a good idea. I think ultimately we should move it to its own file, but for right now, let's just put it here.
Just gonna copy those. So I'm just gonna move over all of the ones that are lightning.
I think that's fair. And they're the ones that really are going to test the lightning functions.
So we're gonna want similar setups, but before we get into the setup, where is our test main? Let's make sure we add this test group here so it actually runs.
Oh, yep, that will increase happiness.
I miss that stuff all the time. Now let's see. We're gonna want a similar setup, so I kind of want to split this out to its own function, but I'm not gonna do that right now. I'm just gonna paste it in there for the moment.
Yeah,
And then
that's another.
Make sure.
That's a refactor for another day.
Mm-hmm. And really broken. Oh, these are not in the proper test group.
Oh, right. We changed their runner, but not their test group.
Mm-hmm. I'm gonna move these down to just above the test runners, just so we can stay organized.
Yeah, that's fine. And so if you're at home and this screen seems to be jumping around a lot, normally we have these windows expanded, and so it's just a little bit easier to. It doesn't jump quite so much. Lily also navigates code faster than I do.
I just like do this like a maniac. I don't know. We have something. Oh, we're not running that test case. I was like, everything's passing, yay! But wait, we wanted something to fail.
Yeah. So.
Where is my loop? Should call lightning.
Oh, right. We really should put
one.
that in the runner.
One thing that's kind of nice to do every once in a while, if you just like did a bunch of stuff and like a crazy person and didn't remember what you did, is to like just make sure you have the same number of test cases as you do these run test cases. So like sometimes I'll just search the whole file for those and just make sure those numbers match up.
I think that's a
Because
really
sometimes
good idea. Yeah.
If I hadn't caught that, like yeah, everything's passing. So let's test on hardware now, and then that test just gets lost in there.
Yeah. And then we would have gone and looked into the loop function and said, "Oh, I know why it wasn't happy." Okay, there we go. We have our failing test. That means I get to go implement a thing. I feel so privileged. Okay. Test LED to C on line 82. Should call lightning. Expected one was 0. So I'll bet if I go and look at loop, there is indeed a shortage of calls to lightning. All right, and now I'm paranoid about this. Okay, I think that's good. We'll find out, won't we? No. I broke something else. Test LED on line 68.
Oh, loop.
Loop should turn LED on. Oh. Oh, yes, that is going to be an issue. I actually want to... let's go look at it, but I think we want to get rid of this test. This isn't...
Mm-hmm.
This is such a specific test. This is very hardware specific, and we know we want to get away from that. what we're really testing here is loop should call lightning. We have another test that does that. Are you okay with getting rid of this?
Yeah.
Okay.
Hmm.
In that case, let me try running my tests again. Oh, that is mad. Oh, and that is because I deleted a test, but did not delete it from my test group. I'm trying to find the line number where that is. I was really hoping that would tell me. It is not going to do it.
Yeah, I don't see one.
Test group runner.
It's like 119.
Yeah, sure turn LED on. Okay, now of course I'm searching in the wrong window, but I'm going to copy that text so I don't have to type it twice. There we go. That was just sort of harassing test. You're right for each other to make sure you're at least getting started on the right path when you're doing evil pair. All right, that's good. And that's something to keep in mind too. Like you write tests all the time that you're going to wind up throwing out later when you're developing software because the design of what you're doing is evolving. You start with one idea and then you realize, well, I have to sort of abstract that away. All right, I think that means it's time to make a release build here. I do have. This is that situation where I don't remember what the magic incantation was to trigger an actual release build. Final. Magic word is final. So that triggers our release build, and now I can make Flash Stormlight. I think that'll make it work. No. Port B is undeclared. Now that's fascinating in hardware.c. In our test, that wouldn't happen because we declare that in a hardware mock. So, in fact, I believe those come in. Yes, those come in AVR io.h. So in hardware.c, I'm just going to go and put that in. Yeah, it's not showing up. It doesn't show up in there at all. So. Look at that. Like, it knew I was coming. Oh, look at that. It's flashing. It flashed. Okay, it's really hard because the glare, but we are getting coming on and off. This obviously looks nothing at all like lightning. All right, we've got 10 minutes left in our stream here. Do we want to take that 10 minutes and just sort of experiment with what happens on the hardware?
Yeah.
All right, so I want to make a bold assertion that a full second is too long to be a multiplier there. And I actually want to, let's try hundredths of a second. The other concern I have is that.
Is that,
Go ahead.
is this the syntax
Yeah.
to get a number between
No,
0 and 100?
this is to get anything within range of an integer, which I think is a 16-bit integer here, which is quite long. And we could get some times that run, we're hanging out for an hour or two waiting for that thing to change. So let's try just tamping that down at first.
Okay.
And then I think we should also probably try to cap it like, hey, you really can't be on for more than like a second or two, or off. So make flash Stormlight. Okay, it's flashed. This is a very long off interval.
It'd take a while.
Okay, we should definitely set an upper bound. And we'll have to back this code out, but because all our tests will fail. But we can write tests that are around it based on what we learn out of this. So let's say modulo. I don't want to.
Half a second.
Oh, you want like half a second to be the maximum?
I think so.
Okay.
Think about lightning.
Yeah. You're right. You're right. I want to get ambitious with the parens around this because I actually don't know order of precedence here. I think modulo comes before multiplication, but some things are faster. But this is a long off interval here. Oh, I know what's going on. We're we're only doing the same thing here. We aren't doing it down there at the off duration, so we get long offs and short ons.
Whoops.
Okay. So let's do that. I feel like that feels like the sort of thing you want to encapsulate into a function. This is a little better.
Yeah.
And I realize this doesn't really look that great over the video. Okay, it looks a little better that way. The glare is taking it out. So I have my perennial problem here of I need to set up my space to protect that better. Oh, that was pretty good actually.
Mm-hmm.
I like that. All right, I want to turn that off now because I'm worried we're gonna give somebody trigger an epileptic seizure. I'd hate for some poor innocent person to be watching our video, learning how to make electronics, and
Oh.
suddenly go into a seizure. For another project, we had to investigate triggers for that, and we weren't risking it there. Hey, you know why you're always supposed to use a coaster? I can just put a ring on my desk. It doesn't make me happy. The good news is you lift those out with denatured alcohol. So, and that's a thing as a camper and a woodworker I do keep around.
I didn't know that.
Yeah, you dab it on, and once you see the ring fade, you wipe it off right away. All right. Yeah, so that's not perfect, but I think it's a good start.
Mm-hmm.
You know, and if I sort of like the idea that this is a project that people they're gonna see this, and maybe they're gonna look at some of the other things we're gonna produce around it, the plans and some instructional videos, and they can take this home and they can experiment on their own about how do we make lightning look more like lightning.
Yeah.
I think that'll be a lot of fun for people. All right, so let me back off what we did in there. You know, that would have been a really great time to commit.
Yeah.
Okay, that's where we were before. So, yeah, if we would have committed to Git right there, it would have been a lot easier and a lot safer to go back to where we were instead of having to remember to control Z back to where we thought everything was okay. We could have... Oops. This is an interesting location I've just changed to. I'm going to have to... I've never seen that folder before. So we're back in our Stormlight folder now. Let's go to our build and let's make test. All right, test is good. So we've got that going for us.
Let's commit now, and then I think
Yeah.
we have maybe a little refactor to do here.
Yeah, I think our lives will be happier if we create a function for figuring out flash durations.
Mm-hmm. Something like get random delay.
Yeah. You know what? Before I get crazy with just wildly committing, let's take a look at our status. Hey, look at that. We created a bunch of files. Oh, wow. Hardware is untracked. I didn't check in the work that Butch and I did last week. Glad nothing happened to my computer in the interim. So there's that make file, and I think that is a leftover from something you and I did. Yeah, that is. Where we're trying to spike out how do we find a... How do we get the Arduino IDE to surrender its secrets to us?
Mm-hmm.
All right, these other files need to come in. I am curious about that particular one. Oh, okay. Yeah, we discovered that Unity does not by default build in support for double precision numbers. So we had to add that. Because in the embedded world, you often don't have double precision numbers.
Oh.
A lot of... it's it's new within the last 5 or 6 years on ARM processors. And we're still actually working on card number 1, I think. Off the top of my head, I don't know my cards. Let's go take a look at our project board. And of course, this is not my project board. And there's every chance I don't have a project board. I don't remember if I do for this or not. But if I do, it's going to be really cool. I've got to sign in and register, so we aren't going to do that. We're not going to do that right now. We're going to go back and work on our code and not bother the poor project board. It didn't do anything to us.
I like the kind of flashes.
Yep. Okay, we've got that pushed out. And we're at an hour now, so I think that's a good point to call it. I don't like to... Watching somebody code for an hour, I think, is stretching the bounds of patience.
Mm-hmm.
So we can let them go off. So I guess we'll see folks next week. Do you have anything that you need to add?
Nope, not really. Just
Okay.
Good night, everybody.
All right. And if you like this, if you find it useful, introduce your friends that you think might like to build their own animatronics. Because that's what this is. It's not just a couple of geeks fiddling with code and electronics bits. This is animatronics, which is a much more impressive sounding hobby. If you can do this, you can build lots of other... You can build the coolest Halloween decorations. My real motivation for learning how to do all this stuff. All right. And with that, thanks everybody for putting up with us. Go ahead and like this video, share it, leave comments if you